rational inequalities. Again, the idea will be to make sure that you have everything on one side, and 0 on the right-hand side. Now, make sure that your numerator and denominator are completely factored. After they're completely factored, we set each one of our factors equal to 0 and solve for the critical values, as we did on quadratic inequalities. So we have critical values of 0 and 2. These two numbers will go on our number line. They're critical points because they're actually on the number line. Now we're going to pick region points as we did in quadratic inequalities. A -1, a 1, and a 3 will be just fine. Any number in those regions will work. Now I'm going to put them in a little T-bar again for testing. -1, 0, 1, 2, and 3 are the numbers we're going to be using. So let's see. Let's start testing. Remember, all you do is plug them back into the original equation and see if they give us a true or false statement. Whether they're true and false will determine whether they get shading or not. Okay, the -1 first. We're going to end up with -1 over -1 minus 2. That's -3. That's a positive 1/3. Is positive 1/3 greater than 0? Is that true or false? That's correct. That's true. So we want to shade that region. Now let's test this critical point, 0. We're going to get 0 over 0 minus 2. Well, that's just 0. Is 0 greater than himself? No, that's false. So we're going to go ahead and give him an open circle. Remember, had he given us a true statement, critical points get solid circles. Let's test the 1. 1 over 1 minus 2, which is -1. That's -1. Is -1 greater than 0? True or false? That is false. And so we will not be giving this region any shade, so we just cross out the region point to let me know that I've already tested him. Let's do the 2. It's a critical point, so when I plug in, we get 2 over 2 minus 2. That's 0. Well, that's undefined already. So this one doesn't even have to continue. We know that because he's undefined, he's definitely false. We'll give him an open circle. Let's test the 3. When I plug 3 in, I get 3 over 3 minus 2, which is 1. Is 3 greater than 0? True or false? That is also true. So we're going to shade that region. Now we're going to go and write our answer in interval notation as it occurs from left to right. It starts at -infinity and goes all the way up to 0. The shading starts back up again at 2 and all the way out to positive infinity. Remember, because of the open circles, we do use parentheses here. If you need to, go back and review linear inequalities, that video, and it'll show you why this is true. Let's look at one more example of a rational inequality. We have 6 plus 3x over 3 minus x is greater than or equal to 0. And again, your first step, of course, is going to be to find your critical points. So we set each one of our factors equal to 0. So we get 3x is equal to -6, or x is -2. That's one of our critical points. To find the second one, we set the bottom factor equal to 0 and solve for x. X is equal to 3. That's our second critical point. So we have -2 and also 3. This breaks up our number line into three different regions now. So I draw my dotted lines in order to help me visualize and pick my region points. -3, 0, and 4. Now I'm going to go ahead and put those in, -3, -2, 0, 3, and 4, so that I can start testing. And remember, in testing, all you're really doing is plugging back into the original equation. True statements will warrant it being a solution. False statements mean it's not. So let's take a peek at this one. -3, that's going to be 6 plus 3 times -3, that's 6 minus 9, or -3 over 3 minus a -3, that's 6. Negative 1/2. Is negative 1/2 greater than or equal to 0? True or false? That is false. So no shading for this region. Let's look at negative 2 now. 6 plus 3 times negative 2, that's 6 minus 6 or 0, over 3 minus a minus 2, that's going to give me 5. Is 0 greater than or equal to itself? That's true. Negative 2 will receive a solid circle. 0. 6 plus 3 times 0, that's 6 over 3 minus 0, that's 3. Is 2 greater than or equal to 0? True or false? That's true. This region will receive shading. In testing our next critical point, 3. 6 plus 3 times 3, that's 15. 3 minus 3, that's 0. Okay, this number is undefined, so it doesn't matter if it's true or false. Because it's undefined, it's definitely going to be a false. And we'll test the 4. 6 plus 3 times 4, that's 6 plus 12, or 18. And 3 minus 4, that's negative 1. Negative 18, is that greater than or equal to 0? True or false? That is false. So no shading for this region either. Interesting about this example, it does show the fact that we can get solid circles and open circles in the same solution. And our answer, as we write it down in interval notation, will be bracket negative 2 to 3 close parentheses. Remember, you always write your solutions as they exist from left to right.